Hi, everyone. This is Beth Boudreau. I'm the Director of Professional Education and Training at Navident. And we're excited to have you all here. I see we have doctors from Texas and our friends from New York, California. Thank you for joining us. We really appreciate it. I would like to say that I apologize for the technical difficulties and the confusion in getting into this meeting room. We actually had two set up, so I thank you for your patience. This training is interactive intentionally. We could have made videos and sent those out to you on version 1.4, but we really wanted to make this an interactive experience. So please, in the lower corner of your screen, if you have questions as we go through the presentations, please type them in. We have built-in time for Q&A after each presentation and also at the end of the program. So we are recording this and it will be archived. You can always go back to it and review it as well. So it's a three-part series. Part one tonight is SEL Fusion, the SEL scan with the patient's CT and integrating it into the treatment plan and how to export it. We also will be covering the media browser. So you'll learn how to archive the patient's data to zip format, how to take a snapshot of the treatment plan, and save the patient's media file. Part two, which will take place next Wednesday, the 26th, same time, same place, will cover enhanced planning and viewing functions. So at that training, you'll learn the panoramic view, the new tools related to that, utilizing the new scrolling correlation viewpoint tools. The 3D view has had some significant changes and updates to it. You can actually place an implant in the 3D view now, and we'll show you how to do that. There's a new rotation of implant and crown tool. We'll show you how to bookmark for saving various treatment plans, along with other really nice enhancements. And then part three will take place on May 2nd. That happens to be a Tuesday. You don't want to miss this one. It will be covering the enhanced calibration and navigation function. So we'll demonstrate the improvements to the guidance indicator, magnified view of the drill tip, as well as how to flip the panoramic view during navigation, and how to calibrate any tool such as a piezo instrument, and also support for zygomatic implants. Most of you know that we do offer a hands-on workshop in our Toronto office the second Saturday of every month. So you can learn more about that on our website. We welcome you to come and attend that. And then also we have just built the syllabus for a live over-the-shoulder program at George Mandelaris' office in Chicago. That will take place on August 19th. We haven't even posted it yet. We're limiting that to 6 surgeons. If you'd like to know more about that, let me know or look on the website. It should be posted soon. That's a great course for doctors that are using the system as well as for those that are thinking about getting involved in surgical navigation. Okay, if you look, once the presentation starts, the top of your screen, there will be a full screen tool that you can click on if you want to see the presentation on a full screen. If you click back onto it, you'll see the view you have now. So I wanted to point that out to you. And then our speakers tonight, we have Dr. Arish Kazi. Arish was very involved in the development of version 1.4, the software. He's head of our software research and development department at Navident. He has more than 15 years of industry experience performing medical image analysis, research and development, both at private companies as well as in hospital settings. He's conducted pioneering algorithm development, primarily in the context of image registration. And then our second speaker, most of you know, is Dr. Ido Bermanis. He's the clinical director at Navident. He has a broad perspective on the industry based on his 13 years of private practice in dentistry. He obtained a master's degree in biomechanical sciences. His research thesis was focused on the development of an innovative CT-based 3D biomechanical model for the human mandible, which was designed for biomechanical orthodontic research. So without further ado, I'll turn the screen over to Arish. Arish, the screen is all yours. Arish, I think you're muted.
Sorry, I'll start again. Okay. Hello everyone, my name is Suresh and I welcome you all to the series 1 of our webinar. The outline of my presentation today is as follows. I'll go over the fusion of SEL with the cone beam CT data, followed by the procedure to export the Navident plan to SEL format. So the main idea behind SEL Fusion is prosthetically driven implant placement. So basically why would you want to do that is you want to visualize the soft tissue to plan the crown and the implant in a top-down fashion, leading to a more predictable and higher quality prosthetic outcome. So for example, this is a screenshot of a Navident plan where I have registered the soft tissue scan here, and you can see that I've then planned the crown and implant accordingly. So how do you achieve this in version 1.4 of Navident? The first step is to create a digital model, which goes as input to the Fusion module. How would you go about that? One way is to use an intraoral scanner to take a digital impression. Export that intraoral scan as an OpenSTL format. So almost all the intraoral scanners out there do support exporting to STL. STL is an industry standard format. It's it's an acronym for stereolithography or standard triangle language. Basically, the file stores the surface geometry of the 3D object. Additionally, an advantage of doing the fusion in Navident is potentially you can do all the plan, that is the restoration and implants, in another software, and then export that plan as a single STL file in Navident, as long as it contains the restoration and the implants and the teeth as common landmarks for fusion. So basically, plan all your implants, crowns in another software, and then export as an STL file, do the fusion in Navident, and then you're good to go. So once you have that STL file, you start the import and the fusion process. So over here, you can see that I've already imported a data set here. The crowns and implants are already planned, but this is, I'll show you the fusion process. So you go to Import, Surface Scan, and then you click on Load. So basically you have an STL file copied on a USB or on your drive. You click on it and click on Open. It loads the STL file. This is what the model looks like. It's of the lower jaw, the mandible. And here you see on the left side different steps. And the first step that you want to do is to make sure that your cone beam CT data is more or less similar to your model. So for example, I have the upper jaw here, whereas the model that's scanned is of the mandible. So the first step that I want to do is actually remove the upper jaw or other structures and only have the mandibular structure there. So for that I have two operators. I can use the keep selection or the remove. So what the keep would do is you just click on it and then draw the contour around the mandible and finish with right click. So it will remove everything else and only keep the lower jaw. And now I have some structure at the back. You don't really need to remove that because it's not near the teeth, but I'll just demonstrate the remove selection here. You finish with right click. And then finally, I have some stuff left over from my first click, so I just remove that. Finish with right click, and then you can see that it's more or less quite similar to the model. One thing that's important to know here is that the gums or the soft tissue is actually not visible in CT. So you want to actually remove that in the model. So use the same tools and you remove the gum area. Now in this specific model, you have a lot of teeth here, so you don't have to go and be very accurate in removing all the gums area, but for this model, I'll just remove this outline here. Now the models are both cleaned up, so I moved to the fusion step. And the fusion is actually a two-step process. The first is a coarse alignment. So basically what you do is that you delineate corresponding landmarks in both, or corresponding teeth. Landmark means a teeth. So for example, and you don't have to be very accurate because the refined registration, which is step 2, is going to improve on your initial alignment, but try to be accurate in the tooth. For example, just on purpose, I clicked on the first landmark that I click is actually not the corresponding one, but it's a neighboring tooth. For landmark 2 and landmark 3, I am more or less dead on. You need a minimum of 3 landmarks to do the coarse alignment. You can add more landmarks if required, but 3 is the minimum. So here you can see that the model is initially initialized on the CBCT scan. And after this, you click on Refine Registration, and this does the magic for you. So it's basically attracting the model to the teeth contours. And at the end, you can see that the model is now more or less quite aligned on the teeth. So at this point, if you see that there is a slight misalignment, you can potentially go and add more landmarks and click on Refine again. But in our case, we are good to go. So I can go to the next step, which is Evaluate Registration. And what this step does is that you're given with the 3D view that you saw before, along with 2D views, which show the contour of the fused model. And you can scroll through the slices using your mouse wheel, try to ensure that the contours are aligned properly. And if they are not, then you have some manual tools that enable you to make minor adjustments. So the manual tools are shown in the left pane here. So first of all, we have the surface transparency tool, which controls the opacity of the model. So you can go across the scroll bar and it will change the opacity. So in 3D, you would be able to see whether the model is perfectly aligned or not. And it's not. You have slight misalignment on the left side. And then you have these other tools. For example, you can manually fix the rotation along the 3 axes. So you can change the elevation, which essentially changes the rotation in the anterior-posterior direction. The roll will change the rotation in the left-right direction. And the azimuth actually changes the rotation around the patient. And if you make a mistake, you can always go and hit reset. So for this specific case, I see that there is slight misalignment, as I said, on the left side, so I just change the role, and then I can go under the contour and I can actually move it as well. So then I again scroll through the data, and also I can change the window level to ensure that the teeth have a high intensity, and then I can ensure that the edges of the contour are aligned. And so far it seems everything is good. So then I can at this point take a snapshot for future reference, and in this case, since everything is good, I can just click on save and exit. And when I do that, I'm taken to the main Navident UI, and I can see the model over here. And then I have a few options. So you can go to surface scan. You can actually toggle the visibility of the model. And then during navigation, if you don't want the model to be displayed, you can actually uncheck this box. By default, the imported model will be shown during navigation, and you can completely remove the model as well. And that's it as far as importation and SEL Fusion is concerned. So now let's go to exporting the Navident plan. So Navident allows for exporting the 3D plan with the implants, crowns, the nerve canals into an OpenSTL format. The process is pretty simple. You just open your data browser and go over the patient's name. I have, for privacy reasons, I've just blurred the patient names here, and then click on export. And you'll be given with this interface here. You have several options here. I'm currently only interested in exporting the plan in STL format, so I uncheck all the boxes. And then I click on export, and it will ask me for a location where to export the STL file to. I just browse to that location and click on save. And just to remind you, this is the plan I'm exporting. I have the fused STL model here, and then I have 2 implants, teeth, and the nerve canals. And this is what my exported STL model looks like. We are also exporting the axes of the implants. And this brings me to the end of my presentation. So thank you so much for your attention. And if you have any questions, please feel free to ask. Okay.
Okay. Does anybody have any questions for Arish at this point? If so, just go ahead and type them in, and we'll address them. We also do have time at the end of the program for questions as well. Okay. Well, then let me introduce Ido. Ido, the screen is all yours. Thank you.
Thank you, Beth. Hi, everyone. So let me share my screen with you. Okay, so what I'm going to go over is the recording of the screen and taking snapshots, which is any option that we have. And eventually I will show you how to export the patient's plan and archive it. So you can note here on the lower right corner of the panoramic view, you can see this blinking red dot. This is a new indication. We had the option of recording the screen before, but now we have that indication. So whenever the screen is recorded, this red dot over there, that right now is not blinking because nothing is happening on the screen, but when I move my cursor on the screen or I do any editing of crowns, implants, etc. in the planning mode, This red dot will start blinking and will indicate that the screen is being recorded. The screen is recorded, of course, during the navigation itself. Now, by default, this option is activated. If you wish to deactivate this option, you go here in Settings, that's the lower left corner, and here in the line Capture Screen to Video File, you simply unmark this square. You just need to remember to mark it again if you wish to record your planning or your navigation. A new option that we have is here in the side panel. You can see this new button that says Snap on it. This allows us to take snapshots of the screen like this. So you can take as many snapshots as you wish, use them later on for yourself or to share it with others. Now, in order to view these recordings or snapshots, we have a new functionality which is called the Media Viewer. In order to get to the Media Viewer, we click here on Data. Then we select the relevant patients. And you can see here in the lower part of the screen where the CT scans are, you can see there's a new button that is called View. Once I click on that button, I'm presented with the Media Viewer. So you can see on the upper left, you can see the patient's name, and just underneath there are two subfolders. One is called Recordings, and one is called Snapshot. So in the snapshot, if I click on snapshots, I can see the two snapshots that I just took. Clicking on each one of them will open the snapshot and I can view them. If I right-click on each one of them, I get this drop-down menu, which allows me to, first of all, open the snapshot using with system default. That means any viewer that is installed on your system, and then you can also edit this the snapshot. It allows me also to delete a snapshot or to open file location. That means the folder where these files are stored. And you can also use it to copy to another folder. You simply click on it and then browse to the folder which you wish to save it to and select the folder. In the same manner, if I click here on Recordings, you can see here two subfolders. The recordings are divided according to the date when they were taken. So if I select this folder, you can see here that there's a recording of the screen. If I left click on it, it will open the recording. This was a relatively short one. Maybe we can try to see here. There's another recording, simply runs here. So you can see everything that was recorded. Now when we right-click on that file, we have the same option, only here we have another option which is convert to WMV format. So if we wish to convert the file to a WMV, we just click on this convert, and then the converter will start working and will convert it into a WMV format. You can still work in the background while it does it. Depending, of course, on the file volume, it can take. If the file is relatively small, it will take some short time. If it's bigger, it will take a long time to convert. Now, the converted file is stored in a folder that is called converted to WMV. It should appear here. In case that it doesn't appear, what you have to do, that will happen the first time that you will convert for a patient. You simply right-click on the patient's name and hit the refresh. Again, refresh. Here. Now we get the converted to WMV. and we have the converted file. Now, the last thing I would like to show you is how to export or actually archive the patient's data. So for some reason, this ruler is hiding the buttons here, but there's a button here in the data browser that is called Export. So if I click on Export, after I select the patient, and I mark this here, there's a line that says Archive all patient data in zip format. So I mark it and click the Export. Then I can select where I want to archive my data, and it will save it in a zip format in that folder. So that would probably be all for this time, and I will return it to you now, Beth.
Okay. Thank you very much, Ido.
Thank you, everyone.
Okay. We have time for questions. Does anybody have any questions for Arash about the STL, exporting, creating, or anything for Ido related to the media browser and how to save screenshots and videos, etc.? If you do, just type it in, and we will get to those. Oops. Okay. No one has questions? You must have done a really great job then. Okay, well, I hope to see you next week. So as a reminder, it's Wednesday the 26th, same time, same place, and we'll make sure to get the right URL to you this time without any confusion. And just a reminder, part 2 is enhanced planning and viewing functions. So we'll be going over the improvements to the panoramic view, the new scrolling and correlation viewpoint tools, all the nice improvements that have been made to the 3D view. So we hope to see you next week. Thank you all, and have a great evening. Thanks to our speakers. Good night.
Thank you very much.